start the recording. Share my screen. Okay. Can everyone see that? Just shout it out if everyone can see my screen. We're good. Nice. Okay. Let's get started, guys. How's everyone in general on this pretty average Saturday afternoon, morning? Okay. But anyways, let's pretty much get started. It is recording great. Session 2. So, in session 2, I guess this is just our agenda for today. We'll go over a bit of a review from last week's session. Although we touched something regarding variables, we'll really start exploring them today. We'll be updating variables, and then we'll be talking about their scope, and then there's some bonus features with that. So just a reminder, if you go on Trinket, remember when we're drawing and we're setting up our window, our first function, we have this thing called def setup, and this just runs once. And then we could specify the window size that we're working with, like say the window size for your game. And then after that, following that, we have another function called def draw, which is basically a loop that just repeats infinitely. So right here, print on repeat, that's going to repeat so many times. Then we could specify the background color of our window. So in this case, 255. If you go back to the previous slide, I believe that's just pure white. And then you could draw an ellipse. And then there's another thing, although briefly touched, there's these special variables called mouse X and mouse Y. And that sort of specify the sort of like X and Y, obviously the X and Y location of your mouse. And you could do something with that. You could draw like a circle at the mouse's location, but these only work inside of this draw here. So I know we talked about variables. Do we remember what variables are? Maybe someone could just briefly explain in the chat. Maybe not. Okay. But just to reiterate, variables, uh they're sort of like containers, and they could store values really. So I guess the most basic variable that we have here, we could define a variable called a, and then we could use the equal sign to specify sort of like a value against 20 and 30. But what's cool with variables is that what we touched a little bit on last week was they could be combined using operators like plus, times. We could also do pedmass with the variable. So we have like d equals, you could do like a fraction right here, and then this would print 2. So that's just a helpful feature. So you might also think, why would we use variables? So a good rule of thumb here is obviously you should use a variable if you need to, if you need a value to keep track of, and or you need or you should use variables to keep track of a value that should be changing over time or that's used many times. So if you think of like examples of variables in games, I mean, a player's like HP level, that is definitely a variable. That's probably like an integer or float, like a number. The player's position, same thing with the mouse's position. Score, the enemy spawn rate, so the constant of gravity. So like maybe you're making a sort of like a low gravity sort of game mode and whatnot. Enemy strength. So there's a lot of examples where variables are used and very relevant. So if we go back here, technically you could name variables as anything that you like, but there are some sort of like caveats. So a variable cannot include spaces. The first character must be one of the letters A through Z or an underscore character, so it can't be a number. And another thing is variables can't occupy one of like Python's keywords. So stuff like print, import, or yeah, print, def. I think I'm not too sure about setup, but there's these certain keywords that you can't just replace. And another thing is that Python is case sensitive. So like capitalization is really important. So score here is not the same as score. And even if you add that exclamation mark. So with that, we're gonna dive into like our first quick question. And this one's using mouse X. But before we dive into that, I didn't explain mouse X uh sort of like that extensively. So I just want to go to our trinket here. But basically you could let me get I had prepared some code right here. But okay. But basically if you had your regular from processing import, you're from draw. And remember that draw keeps running continuously. So we could do print mouse X, and then we could do print mouse Y. But let's just see what happens there. So, oh, that's not very good. Let's do this. But I just want to show what you can do with mouse X and mouse Y. Oh, it is saving. Why is that taking so long? Let's run the program. But basically, if you mouse X and Y, they tell you the X coordinates of your mouse. So as you can see, if I'm moving my mouse here, the X coordinate change. And obviously, if you remember that this corner right here is like 0, 0. So that's why it's really small. And if we go around here, it should be around like, well, anyways, it should be around 600, 600. But that's just something I want to touch on before the quick question. With that in mind, I hope you guys pull up the top hat. And this is our first quick question of the day. So using mouse X and arithmetic operators and the ellipse function, how can we make the size of like the circle proportional to how far left or how far right the mouse is on the screen? So you might want to think that maybe you want to manipulate one of these sort of like settings of the ellipse function to make that happen. So just think about that, and I'm going to pull up the top hat. And while I'm doing that, any questions in the chat? Okay. Boom. And let's start the question. So I believe you guys I'll give you guys 2 minutes. I hope you guys remember how to use Top Hat, but if you need help. Okay, and I'm gonna go back to the slide question. So you guys have give you 2 minutes. And someone said something in the chat. Does this only work on Trinket? Yeah. So although Trinket is one sort of like a coding environment, or coding editor, I'm gonna say coding environment. Although Trinket is one coding environment, it has its own uh I have to say like defined functions or variables that you could only use in Trinket. So the mouse X and mouse Y, if you want to use, say, Visual Studio Code and you're using a library called like Pygame, it might be a little bit different. If that answers your question, Niza. Anyways, give you guys a little bit more time. But any other questions? Okay. Oops. Let's check back on the time. Got around a minute. Okay. So yeah. Oh, okay. But yeah, really just, let's get our pointer right here. Really just think about when we're drawing circles, right? Do we like what does the X and the Y represent? That's the location. And then the width and the height. So if we know that we could get the values of the mouse's X and Y, how could we just modify one of these settings? So just think about that. I'm doing that. I'm gonna prepare the code. Okay, gonna check the time again. 5 seconds. Get your answers in. Okay, great. Let's see the responses, guys. Ooh, okay, a little bit divided. Correct answer is, yep, this one is the correct answer. Okay, so let me explain sort of the code. So although we have this code, I did try creating this in Trinket. But basically, if we look at the code, we have our def setup, our background, well, we paint. But the thing is, if we look at the reason why option C was the correct option is if we look at the ellipse, we want to draw our circle wherever our mouse is. So that's why I use mouse X for the X, mouse Y for the Y. But since we want to modify how big the mouse is growing, how big the circle is, we could just modify, if we go back here, since W and H sort of specify how big the circle is, let's just make that valued with mouse X and mouse Y. So in this case, mouse X. So if we print this as well, if we look at the values, if you look down here, the values of mouse X and mouse Y, as you can see, the X value is getting bigger. So that means our width is getting bigger, and that's why the circle is getting bigger. So I hope that makes sense for you. And if you want a snapshot of this code, you could take a screenshot right now. I'll let someone do that. Okay, I'm gonna go back to the regular slides. Okay, so I hope everyone had a chance to answer that. Another thing, oops, let's go right here. So if you recall from the previous slide, we defined like variables like A equals B. So the equal symbol actually has a specific name. It's called the assignment operator. It's just a fancy way of creating variables, really. But basically, the left-hand side is set to whatever the right-hand side is. So here we have like height. You have height equals 170. And the thing is, you can't sort of like reverse or you can't sort of do a reversal like in this sense where the value is on to the left hand of the variable. So when you're making variables, always go from the left into the right. But another thing that you could do with variables is like what the title is saying, you could update it with itself. So say we have height here, we could redefine the value of height by adding +5 to itself already. So next year grow, say 5 centimeters. And then in this case, it'd be print height, and then the printed value of height would be 175. Another thing you could do is you could also overwrite the current content of the variable. So you could theoretically, you could do height equals 170. And then in the next line of code, you could do height equals 175 if that's your use case. Yep, by changing its value. But if we go back right here, height equals height plus 5, there's actually a shorthand way of doing this. All you have to do is all you have to do is specify plus equals 5. But basically, this is like, well, programmers are lazy. They like making things efficient, and actually doing this shorthand makes it highly readable. So I'm just gonna go back here. I am gonna delete this code, unfortunately, but say we have height. I'm around 5'10", so height equals 178. Technically, you could do height new could be 180, and then you could print. Oops, print height new, and then there you go. We get 180. But one thing that you could do, say that I grew 2 centimeters, you could do plus equals 2. Let's put that back here. Oh, and there we go, it's 180. Or if, say I grew 5 centimeters. There we go. Another thing, well, there's minus equals. So say I shrunk 5 centimeters. There we go. But there's multiple variations of this. So you could do times equals, which is really interesting. But basically, doing this is the same as doing this. So they're equivalent. But like I said, variables are very useful because you could modify values however you want. So maybe this could be like someone's HP, like after they take like a health potion or something. Okay. Okay. Let's go back here. So with that in mind, I hope you guys are a little bit more comfortable with using variables, but that's fine. We'll have time to explore that. So let's dive into our first exercise, and then we'll go into our breakout rooms. So let's look at this code. Consider the following code in drawing 2 squares of the same x variable. Okay. So another thing, guys, is there's some code down below that I believe you guys could access. So this is your Google Slides. There's this like little button right down here, and we typically have like you could copy and paste this code into your Trinket. Oh, what the heck? Save. Oops. Oh, I forgot. You gotta add run. There we go. Okay, something like that. Okay, let's go back. So basically try it out. And then after that, so now consider the previous code, but the challenge is trying to make these squares sort of like diagonal. So with that in mind, how could you change the x and the y values so that the locations of these squares just line up like here? And is that okay? And just some food for thought, consider the relevant dimensions of the square. And again, more prompting questions, more food for thought is like, if we look at sort of like the x and y value, like what's the relationship between two squares like adjacent coordinates? So like what is the relationship? What is the location? What is the relationship between the location of two squares? And yeah, why is the y coordinate of the rectangle on the right y height? Okay, let's go to our breakout rooms, guys. Oops. I'm gonna stop sharing. Okay, I'm going to pause recording. Okay, I hope everyone's back, roughly. Okay, I'm gonna share my screen again. Go back to Google. I believe everyone can see that. Yep. Okay. And I think most people are back from the breakout rooms. Okay, great. So yeah, I mean, if you look at the slides here, there's a couple hints. Whoa. There's a couple hints here. This top left corner is like x plus widths minus something. Oh, no. It says I am sharing my screen. Okay. Anyways, but basically if how to get one sort of like square might look like something like this. So this is the copy pasted code from the lecture notes, but basically we define the first square, so it's this guy down here. And then if we go back to the solution here, you might need to add some width and subtract some height from here. So in this case, since we know that each side is 100 pixels, really the width that we're adding should also just be 100. So in that case, if we do that, and then say we added 200, it's displaced a certain amount to the right. And if we do like 300, if we remember our coordinate system, go back here, we know that if you want to if you want to go down, you have to add to the y value because it's increasing in height. And if you want to go up, we have to decrease in height, so decrease the y value. It's opposite to the typical x and y directions they teach you. It's opposite, or it's sort of like the reverse of the Cartesian directions that you learned in like math class, but it's somewhat similar. So yeah, maybe you could take a screenshot of this code or whatnot. Otherwise, I'm gonna go back here. So we've covered, you guys dealt with variables, handling them, modifying them. There's another one important topic called variable scope. So let's go back here. So variables created inside of like a function like in def setup or def draw don't exist sort of like outside of it. So if we go back, uh, one example you could say of a that sort of like mimics this behavior is like the mouse X and Y, because they only work inside of draw X in a similar sense that like they're limited in scope. So that's the terminology. But basically, variables created inside can't exist outside of it, but variables created outside of all functions are called global variables. And using them inside of a function requires the global keyword. That might have sounded like a bit confusing, but let's like dive into a simple example. So if we look at this def setup right here, if we create a variable x inside of it, it could only exist inside this setup. So we have a def setup, background, we have x equals 10, we could print x, we could do all this nice stuff. But say we wanted to use the value of x in this draw function in another function, this is going to spit out an error because it doesn't know what x is. So basically it's like, so in this case, it's x is called a local variable and it's limited in scope. It's a little bit of I guess, a mouthful, but just know that you can't access certain values that are defined inside a specific function. So in that case, to fix our example, we could use sort of like the global keyword. So if we define x outside of any of these functions, so say at like the very first line right here, x equals 0. If we want to use, or if we want to access the value of x, we have to, if we're using it in the function, we have to specify global x. So we create x outside of setup and draw, use the global keyword to tell setup and draw which x to use. So if we go, so if we, let's try copying this code if I can. Let's see if it imports well. Horribly. Basically, if we go back here and we do say x equals 0, we do def setup. Ooh, that is weird. We do print x. Oh, we gotta do print. It does sort of work, but it's better to use global x. There we go. But say that we defined x in here, x equals 100. I mean, it's perfectly fine right now. But if we do def setup, no, def draw, let's add that colon, we get an error. And it even specifies name x is not defined because the x that's used in the draw function here doesn't know where it came from to begin with. That's why but if we create it outside of both functions, so say we use it as a global variable, we do global x, do global x here. Oh, okay, it works, but it's outputting infinite 100s because it's running infinitely. But similarly, it's kind of like this. You could also use it outside. Okay, so that was a practical example. I hope it wasn't too confusing. But just know that there's certain values that you can't use in specific functions, depending on where you define it inside of your code. Again, another example, a bit like what I repeated. So we could create X as a global variable here, create our window, we have our draw, and global X gives us access to this guy to use inside of draw. And then you could use it as a regular variable down here. So I hope that wasn't too confusing. I guess we'll go back, we'll pull up Top Hat again and do our quick question. So look at the following code and does it work? I mean, does it make the circle move to the right? So remember, these hashtags are comments. So the guy coding this says the plan move the circle to the right by incrementing X by 1 each draw cycle. So remember, draw repeats forever. The background, we create X, then we increment X. So just think about that. Does it work as intended? Would it work as intended? And maybe you could even like copy and paste this code in your editor to see if it does work. I don't know. But with that, I'm going to move to the next one. Let's start the question. Okay. So there's a couple sort of like conclusions here. There's 2 yeses and there's 2 no. Oh. Let's see. Yes, the variable X is created. Okay. You guys could probably have different reasonings. Oh, that's session 1. There's different reasonings to go about it, but just think about this. X draw runs forever, and we define X here, but we also modify it. And does doing this actually change a value of X? Because if we want the circle to move to the right, the X value needs to change. It needs to be added. So does that work really as intended? Give you guys 2 minutes. Check up on the time. Okay. I'll give you guys a couple more seconds. Minute 30. See how we're doing on time. Pretty good. Okay. Yeah. Remember, draw loops infinitely. Infinitely. It's like we'll talk about loops maybe in the next couple sessions, but right now all you need to know is that it runs over and over and over. Excuse me. Any other questions? Oh. Kayan, maybe a mentor could maybe help you on those questions. So sorry, I just saw that right now. So yeah, that's another thing. If what is it again? I might not be able to respond to some chat questions, but hopefully the mentors will be on the looking on the chat, trying to answer any questions that may pop up. Okay, I think it's been around a minute. Oops. Well, okay? Let's look at the 8 seconds. Come on, guys. I like the engagement. 27 out of 29. Boom. Okay. Let's look at this. Let's look at the responses. Ooh. No. So most people are saying no. Let's look at the correct response. Yeah, so no, it's not gonna work, but let's look more into the reasoning. So, okay, let's discuss why this is not gonna work. So if we go back here. So remember, draw runs infinitely. But the issue here is that every loop that you run draw, I mean, you have the background, but you keep redefining the value of X. So it's like saying in the first loop, my value of X is going to be 10. Okay, great. And then I'm going to add 1 to it. So now it's going to be 11. And then in the second loop, you're just sort of redefining it again. You're restarting the value. Okay, it's X equals 10. I'm going to add 1. It's X equals 10. It's going to add 1. So really, the circle doesn't move at all. And even if we code this out, let's do size 500. Okay. So, oh, actually, I do have the code right here. Never mind, I prepared it. Okay. Let's look at the code right here. So we have our processing, def setup, draw. So let's see what that actually does. So in order to make sure that we're coding it correctly, one thing that I love doing is just adding print statements. So we know that the expected behavior of X should be, it keeps increasing, right? But in this case, if you print it out, it's actually just stuck at 11. That's why it is not moving. But in order to fix this, we could just delete this. And maybe we could make another global variable up here. And we could access that global variable in the draw. And there we go. It keeps moving. But do you guys see the difference here? So in this case, we defined X outside of the draw function. We accessed it, and now we're able to modify it continuously. And then if we look here, oh, the X value is increasing as what we like by incrementing X by 1 each draw cycle. And that's awesome. So A and B are unfortunately incorrect. Does not recognize variables. No, it does recognize variables like this. Will be redeclared in each iteration, and the circle will move. So yeah. Great. Good job, guys. Okay. Let's check that out. Turn on laser pointer. There we go. So X is maybe one way to, X could just be the way that we draw like the circle. There's other, you could probably use variables in other like contexts, like two variables we can store as maybe the player's X position and the player's speed. And then we could modify sort of like the speed variable to change the player's position, like right here. So if we look at, oh, what the heck? If you look in, oops, if you look back here, X could have been like the player's position, and then when we do X plus equals 1, the speed would just be equals 1 because we're changing the player's X position by 1 pixel at a time per cycle. So if we look at a similar example right here, using a variable for speed lets us easily modify a program by just changing the value. So there we go, something like this. And I believe if we even copy the code down here, remember, there's some full code down here. Don't need to think too much about the some of the other stuff right here. But let's look at this line by line. So X equals 0, that could be the player's initial position. The speed is how much we want to change the player's position. Oh, there's some other questions. Okay. We define our size, and then remember in def draw, it's an infinite loop. So we access the global value X. Oh, should also be accessing the global value for speed. We have our background, we have our fill, whatever. And then we draw our current ellipse at the current location. So that'd be X. Then we just then we change the player's position by a certain amount, which is the speed variable. And then after that, it should be able to draw continuously. So if I play it after adding that print statement, we could see that, okay, now it's going off the screen, but you could see that the value of X is changing. And we could, and say that we added like maybe 10, it's gonna go really fast right now. Yeah. But another thing is, say you had a negative number. So let's start right here. So I'm gonna set the X value all the way to the right, and say you added a negative number. That means we're gonna go to the left. So let's see what happens if we do that. And there we go. So likewise, if you think about gravity, right? Like when a player's when a player jumps, you might need to define maybe the speed button's the gravity constant 9.81, but for if you want to make a player jump, then maybe you need to modify the y value per se using similar code like this. Oh, there we go. I was just talking about gravity. So in real life, the longer a ball falls, the faster it falls. So we can replicate this by increasing the speed over time, really. Oh my goodness. So yeah, y. So maybe the y value is like, say 1000, let's say 0. So we're at the top of the screen. And then once we add like a certain value, then it'll go down increasingly. Not so sure if we have code for that, but maybe it looks something like that. Okay. We have that. Okay, we're gonna go into our second exercise. And this one is mainly just going to use concepts from what I was discussing right here. So we're changing x by a certain amount, which is the speed. So let's look at this. Write a program to draw a circle which moves diagonally down to the bottom right until it goes out of the window and disappears. Is that it? Okay. So think about it. We start at this corner here, so the location would be 0, 0, and we want to modify the x and the y values so that they continuously go down a diagonal. And then a bonus is how do you make the color change, gradually change from red to blue? So yep, both its x and y coordinates need to be updated. So you might need to use plus equals or minus equals. And then for the color of the circle, remember that that we define color using the RGB system. So like how much of red, how much green, and how much of blue. How do we get red? How do we get blue? And like how do we increment or change these color values over time? So with that, I think the breakout rooms are already open.
Yeah, also again, guys, don't get too attached to the room number. I'll try my best.
Okay. I think people are coming back. I guess I'll just wait. Let me share my screen again. Share. Okay. Oh, just wait for everyone to come back.
Oh, come on.
Oh, what the heck? With the participants. Okay. There we go. 40 people. I guess we're all back. Hopefully this one wasn't this one wasn't too harsh. Was it in? Actually, this is like one of my more favorite exercises of the entire Schulich Ignite. But this is maybe one solution I cooked up in like it was math. This is one solution I cooked up while some of you guys were in the breakout rooms. But basically, might want to define our initial position. So maybe at the top left corner, might want to define like a consistent circle size, and then this is the speed on how we want to go off of the diagonal. But basically, you access your global variables. So this is another trick that I just wanted to show you guys, but you could do this. Oh, and I gotta do global change. Or you could do something a bit fancier and just like combine it into one line by doing global X. And then you just separate the variables you want to call by with a comma. That's a fancy way of doing it, or a shortcut way. I don't know. And then what's it again? Okay, I'm gonna show what this thing does later. But basically, and same with this one. Ignore some of these comments. But basically, if we want to draw the circle going from the top left to the top right, we should obviously draw our X and Y positions, draw our circle. But since we're going to the right and we're also going to the left, so if we're going to the right, we need to add to our X value. So that's why we do X plus equals change. If you go down, we do Y equals plus equals change because we need to increase in our height. And then by doing that, we get it going down a diagonal. but what the heck? Why is it doing this? So what draw actually does is, say you have like a canvas, all that draw is doing is painting things on top of the canvas. So if you drew a circle here and then you drew another circle again, they'll both appear at the same spot because they're drawing on the same sort of like canvas or the same drawing. So in order to like reset that, how about you just like clean the canvas by specifying background equals black or white? There we go. So that's fixed. And then, okay, that's great. It's moving down the diagonal. And how do we get the bonus? So remember that to define color, we get fill, right? So we know that fill uses 3 parameters, or it could use 1, but 3 parameters, which is the R, the G, and the B. So we start off with the red. So we choose the max value for 255. And we know that over time, we want to remove the red and add more of the blue. So in that case, we could just say we could just update it based on the circle's position. So over time, we subtract the red based on our position, and then over time, we also add to the blue based on our position. And with that, we get it changing. There we go. So if you guys maybe want, if you guys want this code, you can maybe like take a snapshot right here. But yeah, something like that. Okay, that was a bit too long, but let me go back to the main session. Okay. Yep. So we did something like that. And before we end off today, let's cover some more features. So you might be making games, right? So another thing you want to cover is maybe you're adding text, like a menu or whatnot. So you could also write text in Trinket. So I guess for hello in this case, you could just specify the font size, so text size, the alignment if you want, and then there's text hello. Okay. And then you could also draw lines. What is it again? Okay, but regarding text and lines, one thing that there's a bunch of different I don't even know what this 25 and 50 does. Oh wait, that probably specifies the position and the font size. But if you go back into the speaker notes, if you want to find more notes about like adding text or a bunch of other things beyond like regular circles and rectangles, all that you guys could do is like search up like Trinket Trinket library, Python features, something like that. Or actually, if you go back down here, oh, it's the PyProcessing. So if you go back in the speaker notes and you pull this thing up, you could go to this website and it'll have a list of like a bunch of different, so processing that by, you'll have a list of bunch of different like functions you could use. So if you want to make like curves, like Bezier curves, there's a box. You could load images. We'll cover that later. But I think if you search up text, yeah, there we go. Wait, no, that's Vertex. Okay, you get the idea. But you can have a bunch of other things. Like you could define. There we go. There's documentation regarding mouse X and Y. You could read about it, or you could have like mouse clicked. So this is a very helpful reference. So search up like PyProcessing reference. If you go to reference here, you have a variety of different stuff you guys could explore. We're not gonna cover all of this in Schulich Ignite, but you guys have we're just telling you guys that this exists and you could play around with it if you have the free time. But yep, you could also draw lines. In this case, the first 2 parameters specify the first point, and the last 2 parameters specify the second point where you want to draw. Okay. And another thing is like, how do you want to make this text? If you want to combine it with variables, you could make it move diagonally across your screen. So remember, we could just define text size. which is the font size that we specify. I'll show an example. Text hello, and then since X and Y is the position, we just update it basically. And what's it again? And if you wanted to make a shape fade from one color to another, I already sort of showed it to you, but you could specify the fill, which is the color, and then you could just incrementally add it or subtract from it. So plus equals 1. Okay. But before we end off today's session, I just want to show the text thing. We have had some code right here. But again, you could take a screenshot, but okay, that goes really fast. But we have our def setup, we specify an X and Y, our font size, and then remember in draw, we access these global variables up here. And then in order to create the text, let's specify a font size. So in this case, it'll start off really small with 1. Let's color it black using fill 0. And then now we write the text on the screen with this string hello. So remember text in Python is typically read by strings using these quotation marks. We specify the location where we want to draw the text, so the X and Y, and then we could just add it, and then we could change the X and Y incrementally over time. And then we clean the canvas each draw cycle using the background function. And that's why we get something like this. Well, okay, that is too fast. Let's lower down the font size to 2 or 1. Okay. Okay, because this one. And there you go. You get something like that. So maybe you guys could take a screenshot of this code so that maybe you could run it on your meantime. Give you guys a second for that. Okay. I think it should be good. And then fading colors. Yep. And you just add it. Okay. And I guess we're sort of at the end of the lecture today, but then again, just want to remind you that in order to submit your exercises, you need to go to the submission form here. They're due a week after your session, but we are a little bit lenient. And then there's more details located down here. And okay, and remember to in the Google form, we'll ask you to submit the URL of your trinket. So remember to, if you go to trinket, you go to your share, you go to your link, and then you copy this and you paste it. And lastly, before we go, these are the exercises. So the in-class lecture exercises, they don't count for Schulich Ignite points, but these exercises do in particular. So this diagonal thing, you could sort of like mimic the code that you wrote earlier, and then just adjust it to go from the bottom left to the top right. This one, it's very similar to this one where you have to change the color continuously. And you might also want to modify the width and the size of the circle. And these ones are just for fun. This one's a little bit hard, but if you need help, if you want to attempt these, you could ask me. My name's Adrian on the Discord, so yeah. And that's it. That's it for the session, guys. Any other questions? We ended 10 minutes early. Great. Any other questions? Otherwise, you guys are free to go. Have a good weekend.
Thank you.
You too.
Look at the applause. Thank you.
Excuse me.
Have a great day.
Yep. See you.
Bye.
Have a good afternoon, everyone.
Good afternoon. I like that.
I had a question
Yep.
about handing in like assignments and challenges and stuff.
Oh, okay.
Well, it says that I have to include my name on the file, but I don't really understand what that.
On the
I don't know what that means.
was it again? I think I'm not too sure regarding that. I think it just means like adding If I go right.
Because my name is on the form, but it says I have to put my name on the file.
Like it just asks you to write a comment.
Yeah.
Yeah, it's not necessary, but you can put a comment with your name in it, like in the code if you want. But again, it's not necessary because we can see your name through the Google form, so.
Yeah, so like just like looking down here, you could just add a comment at the very top saying your name.
Oh, okay. Okay, thank you. Bye.
Yep. Bye. Any other questions? Yeah, some things on Trinket. Nothing. I guess regarding that, Taha, a lot of the coding, some of the code's already pasted in the Google Slides, if that's what you mean. Or do you want some of the trinkets I made? Then, oh, like I have some things on Trinket, some tests or something. Taha, I'm a bit confused on that. Do you want sort of the code that I made right here, or? Okay. Oh, okay. Can you just DM me on the Discord? What's it again? I can probably link them to you right now. My Discord is where it is. So yeah, that's my Discord. Oh, you don't have Discord. Oh, okay. What's it again? I don't know if I could share that. Let me check. This is the Trinket code for the text at least. But yeah. I would, although you don't have, although some of you may not have Discord, I do recommend still trying to sign up for it because that's where most of us, that's where you could directly ask forums without like going through the hassle of emailing us. So just recommend that. Hopefully that answers your question. Any other questions from the students?
On a side note, if we don't get questions, we're gonna start putting you guys in the waiting room because technically the session has ended and we will be moving on to the debrief.